Hello, hello, good morning, students. In the last lecture from this chapter, some basic principles of chemistry, we had studied how to draw this structural formula, electronic structure, and condensed formula. Today, we will study how to draw bond line formula or zigzag formula for organic compounds. So in this zigzag formula or bond line formula, this carbon atoms and hydrogen atoms are not written, but a line indicates the carbon-carbon bond, and these lines can be drawn in a zigzag manner so that the terminals of the zigzag line that represents the methyl group means CH3 group. The intersection of lines that denotes a carbon atom bonded to appropriate number of hydrogen and which completes the tetravalency of carbon. For example, propane in the zigzag formula can be written as this type of line, that is one line, and there is one angular line. So here the single line indicates one carbon atom. I will show this line here, that is a single line. At the end of one of this line there is a CH3 group, and other end that is one more CH3 group. So this is CH3 single bond CH3. One more zigzag line can be shown here. This is a V-shaped diagram which consists of three corners, means three carbon atoms. So it is CH3, CH2, CH3. Always remember that at, at the point of carbon there must be the 4 valency completed. If it is not bonded with any other carbon, then one carbon have valency 4 called as a tetravalency. If carbon is bonded to one other carbon, then both carbon have one valency completed and remaining valencies completed using hydrogen. Therefore, for a single line like this, so at the one end there is a CH3 group and other end there is one more CH3 group. If it is bonded with one more line, or I will show this different type of structure, that is one line, then other line, one more line, other line. This is in zigzag manner. This is letter M, capital letter M, which has corners, means number of carbon atoms 1, 2, 3, 4 and 5. So 5 carbon atoms at each corner of this line there is a one atom. So total atoms are 5, and the formula can be read as CH3, CH2, 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 CH3. So this is the bond line formula, or called as a zigzag formula. Here one example is given as a propane. We know propane is 3 carbon containing alkane having molecular formula C3H8, and here the number of carbon and hydrogen atoms are not shown in the bond line formula, but at the one end of this line there is a carbon which is bonded to second carbon, and therefore first carbon have 3 hydrogen, that is CH3, second carbon have two hydrogen because second carbon is bonded to left side one carbon and right side one more carbon, and therefore valency with carbon is completed 2 and remaining valency is 2, and that is completed using hydrogen. Therefore first carbon CH3, second carbon CH2, and third carbon is again CH3. So this is the bond line formula of propane containing 3 carbon atoms. Like this, I will show one more example of this type. So here, if it is this type of a line that indicates the bond line formula of 2 carbon containing alkane, it is CH3 single bond CH3 that we had studied as a condensed formula yesterday. This is CH3 single bond CH3, and this is a bond line formula for ethane. If there is a one more zigzag line, then it is propane, that is a 3 carbon containing. If there is a one more zigzag line having diagram like capital N, then it is 1, 2, 3, 4 carbon containing. It is a butane. If it is one more line, then it is pentane. One more line, then hexane. One more line, heptane. One more line, octane. One more line, nonane. And one more line is there, that is decane. So total corners for this bond line formula are 10. Hence it is decane. So like this we can easily draw this type of bond line formula, or also called as a zigzag formula. So this is for simple hydrocarbons like alkane. So we can draw bond line formula for doubly bonded compounds, that is for alkene, similarly for alkynes also. And if there is a functional group like alcohol or halide, this different types of functional group we can show in the bond line formula. Here one example of heteroatom containing compound is taken. It is a C2H5OH. We know it is ethanol or ethyl alcohol. The bond line formula can be shown as there are two corners for the line that indicates the two carbon atoms. First carbon CH3, second carbon CH2, and CH2 is bonded to OH. So it is CH3 CH2OH, and it is C2H5OH, that is ethyl alcohol. So this is bond line formula for ethyl alcohol. In this table 14.1, there are some examples given, that is dash formula, condensed formula A type, condensed formula B type, and the bond line formula. Here it is CH3, CH2, CH2, CH3. It is a 4 carbon containing alkane called as a butane. So 4 carbon containing alkane condensed formula can be written as, here the middle two CH2 groups can be written collectively in one bracket, and subscript is given to the number of this CH2 group present inside the bracket, and therefore it is CH3 CH2 2 times CH3. This is condensed formula of butane. Similarly, condensed formula in another form can be written as, instead of writing all these hydrogen atoms separately, we can write this collectively, and this formula is also called as a condensed formula of butane. Can be written as CH3 CH2 CH2 CH3. So this is condensed formula of butane. Now there are 4 carbon atoms. So this is a bond line formula or zigzag formula, in which at this end, left end, there is a CH3 group. Here second carbon at the middle position have CH2. Then third carbon again at middle position, therefore CH2. And here at the right hand side corner, there is a CH3 group. So this bond line formula can be read as CH3, CH2, CH2, CH3. Remember always that while drawing this bond line formula, no hydrogen or no carbon in the hydrocarbon part can be written in the formula. It cannot be written in the this bond line formula. A functional group containing hydrogen, OH, that can be written in the bond line formula separately. And always this valency of carbon that do not exceed more than 4. So it is maximum covalency for the carbon is 4. So always see that the carbon have maximum 4 bonds. So at the left hand side, there is a carbon bonded to other carbon. Therefore, one carbon valence is completed and remaining bonds are 3 and it is completed with hydrogen. Therefore, at the left hand and the right hand corner, CH3 and CH3 groups. While middle carbon, these are bonded to other two carbon atoms. Therefore, two valency already completed and hence remaining valency is completed using hydrogen only, and therefore there are two CH2 group in between left hand and right hand side corner. So here the exercise is given how to write this condensed formula from the bond line formula. It is given here. So from the bond line formula, we can read this atoms present in this formula. So it is CH3 at the left end. Then there is a CH because there is a double bond. If it is single bond, then it is CH2. Again, I will read this. CH3, single bond, CH, double bond, CH, single bond, CH3. And this is condensed formula. If you write carbon and hydrogen here in this manner, that is CH3, single bond, CH, double bond, CH, single bond, CH3. This is condensed formula from this bond line formula. In short, you must able to write dash formula, then condensed formula and bond line formula for different compounds. Thank you.